Energy is the capacity to do any work.
لا ينتج عندما تسبب القوة المؤثرة في جسم ما حركة لهذا الجسم في اتجاه القوة نفسها.
الحلقة اللي فاتت احنا كنا قلنا لو في راجل هيحاول يزق عربية فهتتحرك ويحصل لها تسارع نتيجة القوة اللي هو بيأثرها. طب لو نفس الشخص حاول يزق حيطة، الحيطة ديت هتتحرك؟ بالتأكيد لا. طب هل معنى كده ان الشخص ده ما بذلش قوة على الحيطة؟ بالتأكيد اه. طب الشخص ده بذل قوة على العربية فالعربية بدأت تتحرك، ونفس الشخص بذل قوة على الحيطة فالحيطة ما اتحركتش. ازاي انا عن طريق علم الفيزياء اسمي الظاهرة ديت وافرق ما بينهم؟ قوة اتبذلت على جسم فحركته، وقوة اتبذلت على جسم ولا حصل له اي شيء. العلماء طلعوا لنا شيء جديد في علم الفيزياء يفسر لنا الظاهرة اللي حصلت ديت، وسموه الشغل او الورك. الشغل ببساطة هو قوة بتأثر على الجسم بتتسبب في عمل إزاحة. يعني لو أنا قلت إن في قوة ما عملتش إزاحة يبقى ما أقدرش أقول إن القوة دي بذلت شغل. يبقى الشغل لازما ألاقي تأثير القوة دي على الجسم في عمل إزاحة ما.
وحدة قياس الشغل وكذلك الطاقة. بالفعل، والجول هو الشغل الذي تبذله قوة مقدارها 1 نيوتن لتحريك جسم مسافة مقدارها 1 متر.
The force acting at an angle alpha on this sledge can be resolved into two components. The first one will be in a direction perpendicular to the ground, and the second one will be parallel to the ground. We can derive the value of the horizontal component from the formula cosine alpha equals F1 divided by F. On converting the formula, we arrive at the value of the horizontal component. F1 equals F times cosine alpha. We can derive the value of the vertical component from the formula sine alpha equals F2 divided by F. On converting the formula, we arrive at the value of the vertical component. F2 equals F times sine alpha. Santa Claus is pulling the sledge with a force which is acting along a direction parallel to the ground. The direction of the force vector is the same as the direction of the movement of the sledge, and its magnitude is equal to 100 newtons. Santa Claus covers a distance of 10 meters. Since we know that work equals force times distance, we can calculate the work done by Santa Claus. If we insert the appropriate values into the formula, that is F equal to 100 newtons and the distance S equal to 10 meters, we will obtain a result of 1000 joules for the work done. Santa Claus is pulling the sledge with a force which is acting at an angle of 60 degrees to the ground. The direction of the force vector is therefore at an angle to the direction of the movement, and its magnitude is equal to 100 newtons. To calculate the force acting in the direction of motion, we need to resolve the force into components. The horizontal component is responsible for the work done. We can calculate it from the formula F times the cosine of 60 degrees. On inserting it into the formula, we obtain a result of 50 newtons. Santa Claus has covered a distance of 10 meters. Santa Claus is carrying a parcel. The only forces affecting the parcel are the weight and the force of reaction. The forces exerted on the parcel are acting in a direction which is perpendicular to the ground. Therefore, there is no force acting in the direction of movement. From the formula W equals F times S, we can deduce that if the force acting in the direction of the movement is equal to 0 newtons, then the work done must be equal to 0 joules.
On a rough surface. Here, person applies force on the carton box in the forward direction. This force does positive work, since the direction of the applied force is the same as that of the displacement of the carton box. However, the frictional force on the carton box does negative work, since the direction of the frictional force carton box is opposite to that of the displacement of the carton box. We can say that when a force acts on a body in a direction opposite to that of the displacement of the body, the work done on the body by the force is negative. In such situations,
Although we cannot totally eliminate the force of friction, we can apply another force to a body, which counterbalances the action of the first one. As a result, the body keeps moving at a constant speed along a straight line. This situation occurs whenever the resultant of the forces affecting a body is equal to 0.